Alrighty. Hi and welcome. Welcome to Code About channel. I am Mukesh and I am your host today. And today we'll take care of HD HD44780 displays. What are the displays? I mean, these are just these 2x16 LCDs with HD44780 and drivers that controls them. But for the beginning, but first let's start with small recap what we did last time. So last time we took care of the SSD 1306 display with I2C, and we connected the display. And we have we've connected the display. We have implemented the control using the modem framework, and then we managed to display some text, some image, and also a variable counter that is incrementing every 1 second. So today we'll do something similar. I mean, we'll try to display some text and values, variable values, using this 2x16 LCD. Like this. Oops. So using this LCD, we will try to do something similar. And maybe we'll try also to use both these displays at the same time. If there is also a possibility, maybe take care, because okay, this display is we'll control the with just standard outputs of the microcontroller. But we also have here one display with GPIO expander, and for this we could use I2C. So we'll see. For the beginning we'll start with standard one, then maybe also we'll take care of the I2C piece. Alrighty. For now we must find out how to connect our display to the board. We'll of course again use our BlackPill board. We'll use BlackPill board, and we'll of course use the modm library to quickly generate some libraries for some drivers for this display, and we'll try to control it. Okay, so first maybe let's find out how do we actually, what are the pinouts or standard pinouts of these displays, and what do we actually need. So I was already looking a little bit on the example from modem, but this will have a look in a moment. Okay, so LCD 2x16 pinout. Let's first find out what do we need to connect over here. What are the standard pins that are used for to control this display? Okay, let's maybe go with this one. So first three pins are first 3 pins is okay. Maybe move description inside. Okay. Okay, I'll find the description. How about here? Okay. Okay, so here we have some description of the pins. So first pin is ground. Let's show this. Okay, let's put it over here. No, wrong one. And here we have this. All right. So the very first pin is ground, of course. Then we have 5 volts. Okay. Then we have VEE, which is a pin that decides the contrast level of display, grounded to get maximum contrast. Okay, so I think we'll put this to ground. Register select RS connected to microcontroller to shift between command and data register. All right. Used to read or write data. Normally grounded to write data to LCD. Enable connected to microcontroller and toggle between for data acknowledgement. Data 0. Data pin 0, data pins forms 8-bit data line. They can be connected to micro and to send 8-bit. These LCDs can also operate in 4-bit. In such case, data pin 4, 5, 6, 7 will be left free. Okay, and then we have backlight. LED pin backlight LED pin positive terminal. Alrighty. I already see a small issue that could ruin actually the whole thingy. Because here we are using 5 volts. Can we actually control this with 3.3? That's a good question. Okay, LCDs 2x16, 3 volts. I think the OBS is okay. Starting with some issues today. It's not really perfect, but yeah. OBS, please restart. Ready? Okay, you're back. So, now the question is how to handle this if I don't have any voltage. Anything that can modify voltage and make it from 3.3 to 5. Let's see quickly. Or maybe mine is actually... No, wait. Okay. Good thing is that on this display, I think that we can work with 3.3. I'm really hoping for it, and I will go on with that. Hoping that this one is indeed 3.3. 1602A. Okay. Let's see. I don't really remember where they ordered it, but I hope I cannot find any. Boom, boom, boom. All right. Okay, let's try with 3.3 volts, and then we'll see what is really going on with this. What's going on here today? It looks like my OBS is quite stubborn today, and it doesn't really want to cooperate. It shouldn't happen. Okay, let's actually see in modem which pins are really needed. Okay, so the pins used by LCD when not using a port expander. So in the backlight we could actually skip. We don't need this one, at least for the beginning. Enable, RW, RS, so these three, plus contrast one, which should be grounded, number one, which should be also grounded, 3.3 volts on this pin, and 4 pins over here. Okay, bring some cables. Okay, let's switch camera for a moment. And we need few cables. Okay, male to male. Pom 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 pom. Okay, these three. Okay. Wait. Okay, so first we are starting with, oh, maybe a moment. I will disconnect this power supply, communication, and board it. Okay, so we'll start with some cables, with some cabling, and we need total. We need 3, 6, 10 cables. All right. Okay. Okay, so we have. Okay, for now I'll disconnect the this display. But there's a little bit more space in here. Oppa. Come on. And here, let's make some place. Okay, let's put it over here. I wonder if you can make it so that you can see the display and it's not covered by cables. Maybe. Okay, so from the left, like this. This. Okay, so gray and black are ground. Where do we have a ground here? We have it on the right here and here. But here on the left there's not much space for 2 pins. Let's pick it up. Move it closer. Okay, now with some space. So gray and black. 1 and 2. And then white as a pin number 2. It goes for VDD, which in this case is 3.3 volts. Okay. And then we have a lot of other pins we have to control. Let's select on So we would like to use maybe pins. We need 7 pins. 7 pins. PA0 is used for switch. Oh, cannot see this. PA0 is used for switch, so we cannot use it. But if we use this side, we could go with 0, 1, 2, B0, B1, B2 for this three pins that are RS, RW, and E. Okay, let's go for it. 2, 1, and 0. And together with go for pins. Let's go for pins A4 and A5, A6 and A7 for LCD pins D0, D1, D0 and D1. Oh, yellow is first. So D0, D1, D2 and D3. Alrighty. And now we won't see anything on the screen, right? It's not, maybe not that bad. Where's the board? Okay, and display. Okay. You can move these cables to the side. Ah, come on. How about what if I spin this upside down? Maybe it's not that bad. Maybe. It's quite messy, right? I don't like it. How about if I let's give it a little bit too short. That would be perfect, yeah, but the cables. You know what? Let's start for the beginning like this, and we'll take care of it in a moment. And there's something indeed on the display, alright? I think it's not a big issue. Not that big issue. At least for now. Okay, and we still have connected, we still have our adapter, UART adapter connected here. So it's good, it's fine. Okay, let's power up everything. Question now, is it even working? I'm just wondering. It might not work with 3.3 after all, right? Let's try with pins are I think all pins on the board are 5 volts tolerant, so it should work. Only PA0 and PB5 pin is not 5 volt tolerant, so that's okay. Yeah, we need to work with 5 volts. Oh, come on. Otherwise, this will not work. Nope. Okay, so this display is after 5 volts. I just wonder, what about the other one? How connected elements? What about the other display? Will it work with 3.3? Oh, the other one. Okay. Below the ground. Okay. It's not showing anything. And what about this? It's also not showing anything. All right. Oh. One moment. You know what? Straight. Let's work with this display, and after we finish, we will move on to the next one. We'll see if that one is working or not. If it reacts to 3.3 volts, then pins, then it's okay. If not, then we'll move to I2C one. Because today I'm not been able to get anything that will work with 3.3. I mean, I will convert 3.3 signals from the board to 5 volts on the display. All right. Okay. I don't like these cables. I have another idea. Okay, let's do it differently. I can connect it directly without any port. Cables. So the red one being the power supply, yellow and no, brown and orange for ground. And okay, and again. Orange to ground, red to 5 volts, and it should work. All right. And then we have 3 cables for yellow, green, blue. So yellow to B0, green to be 1 and blue to be 2. Okay, and D02A3, so the purple one, A3, gray to A4, oops. White to A5, oh wait, I made a mistake, I think. Like, let me quickly connect it off the camera. That's way much better. Okay, it's much better. It's falling a little bit. And because they're missing, okay, let's put something under. Not a good idea. Okay, that will do. Definitely. That's perfect. Okay, and now let's reduce a little bit of light. Let's maybe take it away a little bit. Okay, this is fine. I think this is fine. All right. And now let's do some coding, finally. So we have an LCD display connected, and okay, as you can see, main camera, let me see, and now we can go on. So we have a display connected. Now we can configure and generate the project. So let's try to do this. So we have here an example from modem, and this is an example of how for STM F4 discovery. with HD44780 display. And now let's have a look. How do we configure this? So first let's maybe go on with product XML, and in the meantime we will also open our development BlackPill app, BlackPill again, here, code. Alrighty. Okay, so that's the code that we left last time, that we used to work with SSD 1306 display. Let's today modify it, at least for now. Well, actually we need to remove, comment this out, because we will not be controlling for now the smaller one. We'll connect it later, back later. For now, let's just, okay, let's leave it, and then we'll remove this code. So first, project XML, and here we need to put for sure driver module, this one, and also nothing more, I suppose. Nothing more. So let's add this. Oops. Okay, so we add the driver for this 2x16 LCD to our project. Let's now regenerate it and build. Okay, so we regenerated the project, and now we have access to the driver. We should have an access to the driver. Yeah, there it is. So now we can go on with HD44780 display. Okay, so let's go back. Let's open up main and let's see how it's working. Oh, should work that. Example, demonstrating modem driver for displays with PC8574. I actually have PCF8574, but I suppose that's exactly the same, right? So at least I hope so. So, all right. So we need to add this include for the driver first. Oh, before we start modifying the code, let's see if the project was cleared. And there was no uncommitted changes. So the include modem driver display HD. Okay, and with this one get access to our our display driver. Okay, so how is it? Okay, so there's a namespace for LCD. Where is it used? Oops. Okay, that's okay for the namespace. That's okay for the namespace. Ah, okay. You can choose either port with simply by using it. I will handle it internally. Okay. Okay, so we can use this one. Okay, let's go from the top. So first we have a logging, that's okay. Let's add this namespace with LCD. Define the pins used by the LCD when not using a port expander. Okay, let's just follow this. Struct with system clock. Okay, let's create it over here. I actually wonder why is it a namespace. Oh, okay. Alright. Namespace, oops. Namespace LCD. Let's make it with using. Okay, backlight, which is not connected, but it's totally fine. Maybe. Do I need this? Is it used? Just setting as. This is not new because of hardware defaults, but this is better style. Actually, this is not new because of hardware defaults. Are we anywhere using this? This backlight? Okay, for now, let's leave it. Okay, using E equals GPIO. Oh, that's some old style out. Oh no, wait. GPIO output or okay, GPIO output. I'm curious now. It's different approach. Okay, output. What did I connect to? Pin. Where did I connect the E pin? E is number 6. For 6 we have color blue. Blue is connected. Blue is connected to oh god. To B2. So this is GPIO B2. Okay. Using RW. This is pin 5. It should be GPIO output B1 and using I suppose RS. Yes, RS. GPIO output B0. Let's double check. So RS is pin number 4, which here is yellow, and that's B0. Alrighty. So in between there's just B1. Okay, so that's fine. And now GPIO port. Okay. Using data for bit. GPIO port. GPIO output. Oh. GPIO output A4 to A7. A4. A4. 4 pins. Yeah, it was 4. Yeah, it was 4 pins. Start GPIO and width. Okay. Alrighty. Now. Okay, so that's GPIO port. What about this one? I want to see. Ah, okay, so that's totally fine. Just GPIO B0, which is a GPIO static. Alright, that's totally fine. So this is just similar as I used in here. Basically GPIO cp13 is also a GPIO output cp13, so I could use the same. That's fine, that's fine. Okay. Okay, so that's here. How about if I move it to main? It should work. No, it will not work, of course. Okay, let's leave it over here. Now, since we have this namespace and we have our pins defined, we could simply... No, this is for GPIO expander, which we are not using today, at least not for now. You can choose either port width simply by using the driver will handle it internally. Create an LCD object with 8-bit data port. I want 4-bit data port. Okay, let's see we can add there. Okay, that's also quite awesome, because then we don't have to spend that much time on our processor to handle the communication with LCD. Alrighty, let's use this 4-bit. Let's go to main. Up. And here let's create another display. Oops. Okay, since we are not using SSD display right now, I'm gonna just comment this because it's gonna block the application here if there's no response from SSD, and there will not be any response because we are we disconnected the display. So yeah, it's not really possible. Oops. It's too bright, too bright. Oops. How about if I... No, that's too dark. Okay, let's leave it like this for now. Okay, now that we have our display, let's actually see what is in here. So, LCD, data 4-bit, okay, that's fine. What is in here? What if I open it? Width and height, okay, width is 16 by 2. 16 by 2, fine. And I would actually like to make it this way. Alrighty. Maybe I don't know. Let's leave it for now. Okay, so and now since we have this display, we can try to connect to it. Update. Okay, that's thread 1, and we have thread 2. No. What is in main? What's there in main? That's port init. All right. UART for logging. I2C. Okay, here we have LED orange orange LED blinking, and one update. One update is functioning here. That one. Ping the device until it responds. Okay. This one is not needed because of hardware defaults. This is better style. Actually, this is not needed. Okay, so let's set our. Okay, so. Oh wait. One moment, guys. Słucham cię. Co tam? Do kogo? Alright, guys, I'm sorry for that. One moment. Oh, come on. Mhm. All right, let's get back to the topic. Sorry for that short break. Okay. So, I wonder if we have to set pins to outputs. Set output. Set output, pin set output. I think I need to set these to outputs. So let's go for it and set these pins to outputs. Let's do it right before running the display. LCD. Set output. Right, like this, suppose. Yeah. Set output. So let's do it for all the other pins. Okay. It's for E. It's for RS and for RW. Okay. And now let's initialize the LCD. I think. So, okay, we are setting the this is not used of hardware, but this is better still because of initialize. Okay, display initialize. Display initialize. They are saying that sometimes displays are not working with single one. Initialize twice as some display are not initialized after first try. Fill CG RAM. Wow. Set cursor. Okay, let's actually copy this. This CG RAM is not needed, actually. And let's try like this. Oops. Hello code above. Code above. Let's see if this works. Scans. If it's building at all. Okay, scans program. And I suppose we will not work with that today. Or are we? Okay, let's connect back our adapter and see if the application is running properly. All right. I'm afraid we might have an issue with this today. So ground, and what are the other pins? What was the connection for them? think it was I don't remember where were they connected. Oh wait, should have this in configuration. GPU A9, 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 A9. Okay, A9, A9 and A10. But I don't remember which direction. Wait, actually, the blue one to A9. Okay, let's try out. Oh, there's nothing coming from this. Wait, am I transmitting any messages? I think I know. No, I think I'm not transmitting anything, right? A9. Okay, so oh wait, there should be some transmission coming. White is ground. Okay, something weird is happening. A9. You are to connect GPIO output A9. GPIO output A9. So it is connected properly. Let's maybe open up terminal. Sudo screen dev tty USB 0 115.200. Oh, okay. Dev. There's no such thing. Ah, because it's disconnected, of course. Maybe that's why some parts were just not working. Oh, wait. Okay, so I was supplying the board from okay, now I have some communication. Let's open up again. Let's see if something is coming. Yes, we have something coming. Alright, so let's try out again. 3.3 volts. Oh, it's not working. So yeah, we might have an issue over here, and it will just not work. This might not work today, since we don't have 5-volt pins, and 3.3 might be not enough. That's bad, actually. That's not that good. Indeed, this might not work. And I'm not happy with that. Definitely not initializing. But let's try. Let's see if the. Okay, and let's first switch to this text. Right. Info. Oops. Info. But still, let's here do this. Let's see the example. Display init done. And display text text displayed. Let's see. Okay. So yeah, we definitely have issue with our text displayed. Unfortunately. Unfortunately, this will not work today. Not with 3.3 volts. Not with 3.3 volts communication. That's a shame. Okay, what about the other display? Let's see. This one's screwdriver. Okay, and for the moment I need 3.3 volts to connect, and yellow is ground. This one is here. Something is visible over there. What about if I connect this to 5 volts? Yeah. We have another display that's working with 5 volts. That's even worse right now. It's the pin. Okay, this one is for. Okay, let's try with the other one. Let's see if this will work using the I2C communication. If not, then we'll have a small problem over here. But we can handle everything, right? If not today, then next time. B6, B7. Okay, let's connect the display to I2C. Let's change the connection. Sorry, but I didn't expect this. Okay, I need 4 pins. That's perfect. So we have brown ground, red VCC, SDA is orange, and yellow SCL. So brown ground and red 5 volts. We'll see if this will work with 3.3. If not, then I'm gonna have to do something different today. And orange is SDA, PP7, and PV6 is SCL. Alrighty. Okay, and let's go power supply. Oh dear. Okay, this cable is dead. Okay, let's do like this. Okay. That's better. Let's see if this this configuration will work. If not, then well. Okay. So I need to change right now. Wait, I could actually use this one, I suppose. Still working? Yeah, this one is still working. But it's not doing the display hello code. No. Oh, it's getting stuck somewhere. Doesn't matter. All right. Let's use the other part of the code. That is actually okay. Where's the expander structure? Okay. I need to copy this and put it over here. I'm not gonna touch it. It should work as it is. Because that's the configuration of the expander. Okay. Let's now create the let's now create this one, this display. No, okay, yes, this one. this one was failure. Okay. Oh, we need one more thingy. Because without it will not work. We need this driver. That's the expander driver. Okay. What else do we need actually? We need to include. Okay, first we need to rebuild the project. I'll build. Okay. Fine. Expander data. Wait, is it other? Something is wrong in here. No, yeah. Okay, it should be fine. Okay. Okay, so after we create the master, we need an expander. Okay. What? I need to do it from the beginning, otherwise I'm gonna mess something up. Okay, so we have the master. We need the expander. We need the expander. And we need this. Okay. Oh my goodness. Okay, let's remove this one. Let's clean up a little bit because now I have a big mess over here. And yeah, I have too much code in one file. This is already bad. Okay, expander. Okay, let's do it like this. Actually, okay, I'm gonna change this a little bit. Because why not? I'm gonna regret this. Okay, so I have the code of. I have this. Oh, damn it. I have this expander code over here. I'm gonna make it with using. Okay. Oh. Just yank it. Okay. And now using rs equals this. Okay. using and oops, using can also clearly put like this or this overputs. What? Okay, 7 pin 7. Okay. Ah, there's it. Okay, let's clear out this a little bit. And here's also using. And here we have, let's make it one line. Okay. Oops. Equals. I don't know if the Vim keyboard is good for such things, such moving around. Maybe I'm just not using it properly. But, well, who cares? All right. I could actually add an exp over here. Wait, what? Why is it P44 over here? Wait, from a... Okay, whatever. I don't need this one, right? Or is it? Okay, it is needed. Let's keep it. Okay, so what do I do now? Okay, now I create a display. Now I create a display with this. Okay. Oops. Display 16 by 2. Okay. Let's remove this line, this. Okay, now I have a display with these pins. Oh, wait, not these pins. Like that. Okay, that should do. And now in here, I'm gonna have a look on the expander. Expander, no, backlight. Setting all 5 to output. XP. exp, exp, and also backlight. Backlight. Set set output. I wonder why is it not working properly. Something is gonna come out soon, very soon. Okay, and the rest should just work. Let's try to build this. Something's gonna, yeah. Oops. Doesn't name a type. GPU expander type dev. Wait, where is it? Oh, this. Wait, where's the expander? I had to find it somewhere. Okay, I didn't. Looks like I didn't. My bad. Okay. I created pins, but I didn't create expander. That's why. Okay, I need this thingy. Okay. Oops. Using GPU expander. GPU expander was okay, and display I square C. Display I square C. Now it should work. Display I square C. Now all this should work. No, it's not. Definitely not working. Stubborn. Okay, I need to see skulls minus J8. Okay, what's wrong with you? Static storage duration. Okay. So I screwed up. Okay, let's move this outside then. This display. Okay, let's move it outside then. Why not? Let's move this out from main. Okay, let's use LCD I square C, just like that. LCD I square C. Let's try to build it now. It's not been declared. X data forbid. Bit GPIO, I suppose. A moment. Wait, where is it? Ah, 4-bit GPIO, of course. So maybe it will work. GPIO. Okay, let's try again. Okay, it worked. Let's go on program. Oh! Oh my goodness. Basically, it worked, but in the meantime, I made a big mistake because I didn't notice that there's improper bed screen, bed scene on the screen. All right, so let's make a small summary what I just did. So using this project. Oh wait. Okay. Ah, my goodness. Moment. Is crushed. Okay. Right. So. God damn it. Okay. I'll remove the camera view because this is all the time annoying. When I forget to push the screen, and it's not the first time that I forgot to do this. But in overall, okay, let me show you what I just did. So basically, using the example on the website of modm, I took some parts of code. I took some parts of the code and okay, I took some parts of the code and adapted it, modified it a little bit because I prefer using instead of typedef as a better better replacement. And so I configured all the pins exactly the same as we have in here. So these are pins that are connected. These are actually pins on the expander. P0 to P7 are pins on the additional chip that is connected on the back of the LCD. And using this configuration, as I did over here, with this configuration and with GPIO expander connected to I2C master, I was able to create an object of that display with size 16 by 2, and then I was able to initialize this display and write a message on it. Let's now try. I'm thinking about connecting another display on the same I2C, and I would like to try to work with these displays at the very same time, and wonder if this would work. So maybe let's try it. Okay, this is not needed. Okay, let's commit as it is, and then we'll clean this up. All right. Commit. Git add. Git commit. Working an LCD 2x16 with I2C output IO expander. Okay. Now let's modify this. Let's modify to see if this will all this will work. Let's first let's see if with just one initialize this display will still work. So let's program it. Scans program. Okay, let's disconnect the power supply, connect it back, and it's working. Okay, this is perfectly fine. Git add, git commit, removed labeled display unit. All right, so let's now try to use also this second display. Let's rename it to wait, is it OLED SSD CD? Okay, this is an OLED. All right, so let's call this just LCD. So display change work to LCD, LCD. Okay, and let's call this one OLED. Oops. What did I just do? OLED. God damn it. Okay, but let's now uncomment this, uncomment this part. Let's connect the display and let's see what happens. Okay, 4 pins and for cables. The first one, ground. Okay, let's put it like this. I just hope this will work. Okay, so we have SDA on PB7. Right behind you. Next one is blue on PB6. Then we have ground gray. Okay, ground is gray and here this one. Okay. Is it not working? Something is wrong. Already destroyed something? Okay, let's see. Ground is gray. And something here. Oh. Wait, did this display work without anything? Let me check. No, it's just dark all the time. Alrighty. I was already scared that maybe I just broke a display, but it looks like it's fine. So again, SDA is on PB7. SCK PB6. 3.3 and gray is ground. Gray is just ground. Alright. Let's now try to program it. Close program. Will it work? Let's see. Oh my goodness. All right. That's a good one. Let's actually a bit more. Okay, so the very same. Oh, do I put it over here? Okay, maybe like this. All right. God damn it. Oh my goodness. Maybe, you know what? In the front way. Here. Okay. Next time I need to prepare something bigger. Yeah, I'll just show you after I flash the board with proper code. Okay, let's now go back to the code. And let's see. Okay. Since we have a counter over here, we could actually remove these 3 lines. Okay. And these three little signs, and we can go to LCD and set cursor to column 1 0 to LCD counter. Let's now program it. Let's see. That's just no, wrong one. 0 and 1. This will work just fine. Now we can see. So here on the big display, it's too bright. Camera cannot catch this. Let me play a little bit with this. I have an idea. Oh, now it's too dark, right? Right. Backlight must be there. Let's have, okay. Okay, so I turn it off. Oh wait, maybe that's a big light. No. Okay, let's modify a little bit camera gain. Maybe this will help. For these, configure gain, exposure. Here we have it. A bit better. Oh, there you are. Okay, so now we have More light? No, okay, that's better. That's way much better. Okay. That's too bright. Okay, like this. And here we have another display. Yeah, I'll just show you like that. Or I will just maybe connect it with some other cables. Connect it, put it back on the board. But then you're not able to see it. This will do. Okay. Let me quickly connect this board, this LCD back to the board. And again 4 cables. Okay. Purple colors that I don't mess up. Okay, screw it. One, number 2, number 3, number 4. Right, and now B6 is SCL. So blue goes over here, purple goes over here, and I would almost burn this down. This is 5 volts, and now the purple is going to purple, gray is going to ground, and white is going to voltage. Okay, where's the pink? All right. Okay, now you can see the final result. Yeah, so I have 2 displays connected with the same I2C, and they are displaying the same counter value. No, wait, they are they? I messed something again? I thought they are displaying. Wait one moment. There is a mistake in the code again, possibly. Okay. What do I have in here? Ah, of course, they will not display the same. Okay, let's just like this and counter plus plus. Now they will display the same. Yep. Now they display the same value. All right. Yeah, that's true. Okay, so to sum up, to make a small summary today. First, and that's the most important thing, I will not use camera screen anymore, at least not as it was done like today, because it's making many trouble. I forget to switch back to code, and today you could see how I was basically, you couldn't see how I was coding, which is bad, actually, very bad, because I forgot to switch the scene, and you could only see displays. Okay, so some small devlog. Small devlog. Removed camera. Again, coding done behind the scene. LCD 2x16 not working with 3.3 volts. Volt pins. LCD 2x16 I2C working with 3.3 volts. Connected LCD and OLED on the same I2C. Okay. So yeah, that's a small summary of the stream today. I'm thinking about doing a small video series of a project which would include using this LCD 2x16 and some ADC, probably some ADC rotary potentiometer, some servos. So yeah, maybe not. I'll see. I'm thinking about this and to define what I would like to have in this. There is an idea in my head about making a small shooting trainer, but yeah, first I need to think how to do this. All right, so for today I would close the stream, I think, because I don't have any more ideas what to do with this. I think this text and counter on LCD is good. I'm not planning to do any animations, at least not for now. So I'm not trying. Yeah. I think that's it for today. So thank you for watching. Thanks for coming in, and yeah, have a nice day, have a nice evening, and see you next time. Bye bye.